All right, we're back. We're still on page 120. We were talking about adding and subtracting vectors that are in component form. So remember, to find component form, you do terminal point minus initial point. When we draw our vectors, so for the sum, what we do is we basically just like go in order. You use the first vector. So here you use the first vector. That puts you here. Once you get there, somebody walks up to you, gives you a piece of paper and says, these are your new directions. So from that point, you follow those directions. So in this case, those directions were to follow vector v, which goes here. And then what you do to write your final resultant vector, so the vector that ends up as the result of this process is the resultant vector, which I think is actually not anywhere on this page. So adding, subtracting vectors gives resultant vector. It's the resultant vector. So we end up with a resultant vector. It's the result of adding or subtracting vectors. So you go from the initial point to the terminal point, draw your vector, and then put your arrow, which sometimes you'll put in the middle so that it's a little clearer. But that's how we do it. And then when we wanted to subtract, it was a little different. What we did was, instead of doing u minus v, we really do u plus negative v. So we find negative v, right? Negative v in this problem would have just been the opposite of v. So v is telling me to go 3 to the right and 2 up. So negative v would be 3 to the left and 2 down. And then I just do u plus negative v, which algebraically, like, you don't really need to do the work. You don't really need to show that, I guess. But graphically, it's incredibly useful because if you look at what we did, so here's v, 3 to the right and 2 up. So negative v is 3 to the left and 2 down. Now you just think about the directions, right? Someone hands you a piece of paper and they say, use the vector u. So you use the vector u and you go from here to here. Once you get here, somebody hands you a piece of paper and says, use the vector negative v, which says go 3 to the left and go 2 down, which puts us here. Now the final resultant vector goes from the initial point, which was here, to the terminal point. So initial to terminal gives us this. And then we noticed that this vector is the same as this vector, but then I sort of dismissively said, yeah, it's also the same as this vector, or any vector that is 2 to the left and 2 up, because that's what happens. Oh, it does tell you that here. Look at that. There's a resultant vector. Good job. So the result of adding or subtracting is a resultant vector. That's good. Okay, so what we want to do here is we want to do this with 3 vectors. And I'm going to do it. I'm going to do it by hand here. But what I wanted to do first was just bump over to GeoGebra and see, because we can like pick them up and we can move them and we can like think it through a little more clearly. So I set this up ahead of time. And there's kind of a lot going on. So I defined the vectors just by typing vector and then the ordered pair. So like the vector u should be 1, 1, then 1, negative 2 is v, then w is 3, 2. So I typed those. But then I decided that I wanted to put them on these points. So what happens is if I pick this up and move it, right, it doesn't change the magnitude, it doesn't change the direction, but I can kind of like control where the initial point is. So in component form, still exactly the same. But as I move the initial point, I'm also moving the terminal point because the set of directions remains the same. And the way it's set up now, it's just a little more convenient because I can pick them up and move them, right? If I want to do, so say I want to do u plus v plus w. So I'm going to put u here. I've used that. Now I'm going to use v. So I have to go to the terminal point of u and just put v. So this is why I did it this way. And then at the terminal point of v, I'm going to use w. And then the final vector would go from this point to this point. And that would be my vector u plus v plus w. But that's not what I want in this case. What I actually want is u, what do I want? U plus v minus w. So I actually need negative w as a vector. So what I did was I created this extra point so I can do that. And I'll show you down, if you look at the bottom here where I'm typing, you can see how I create that. So I'm going to create a vector. It needs a starting point and an ending point. And this is a little weird. So it's going to be D is my starting point. But you can see right now it thinks that that's the terminal point because that's another way of creating vectors. That's not what I want. I'm going to give it another point, comma. So the other point is going to be, you're starting at point D, and then you're using the vector negative W. So I'm going to say D minus W. And I will press enter, and it's going to name it something, maybe X. No, A. Okay. What I'm going to do is I'm going to rename that in a weird way. So let me see, settings. I'm going to rename it as a negative W, but I'm naming it as the caption. So here, and that's strictly because this is W, right? And so negative W is going to get, maybe if I got it on the lattice point, there we go. There we have W and negative W. They're in exactly opposite directions. I'm also going to turn the label off on this point. All right, so here we go. I don't actually need W anymore, so I'm going to just put it up over here, kind of out of the way. All right, so first thing I'm supposed to do is U plus, so they're all in component form. So when they're in component form, they're all just sitting here at the origin. But somebody walks up, they give you the directions, like the first thing you're going to do is U. So that puts me here at 1, 1, right? I use the vector U, I go 1 to the right, 1 up, I'm at 1, 1. Now when I get there, it's like a spy movie or something. They just keep giving you more directions. Like, okay, you're there. Somebody shows up, they give you a set of directions, and they say that you are supposed to use the vector V. V is 1, negative 2. So you move 1 to the right and 2 down. When you get there, someone shows up, and they say, now what you're going to do is negative W. So W, we know, is 3, 2. So negative W is negative 3, negative 2. The end result of this is a vector that goes from 0, 0 to negative 1, negative 3. So the end result is negative 1, negative 3. So if I create a vector here, vector, and then I need an ordered pair, negative 1, negative 3. That is the final result. That's U plus V minus W, or U plus V plus negative W. All right, and we're going to do that by hand in a second. The other way we were supposed to deal with this, though, so these are our vectors. The other way we were supposed to deal with it, I'm going to put them all in component form again. I mean, the vectors themselves are in component form. So you can watch, like here, W is defined this way, which is a little weird, but it's 3, 2. If I move W around, that just stays 3, 2, even though the initial point and the terminal point are changing. The relationship between them never changes. It's always the same set of directions. Go 3 to the right and go 2 up. So get this out of our way. All right, so the next one we're supposed to deal with is, let me pull these out of here. So the first thing I'm supposed to do is V, right? So I'm at the origin, somebody gives me directions, they're like, use the vector V. So with those directions, okay, I end up at 1, negative 2. When I end up at 1, negative 2, somebody else shows up and they're like, now use negative W. So that's going to tell me to go 3 to the left and go 2 down. So once I've done that, I'm now at the point negative 2, negative 4. I'm sitting there, somebody shows up, they're like, now use the vector U. And that's going to take me to, look at that, the exact same point. It actually doesn't matter what order I use these vectors in, I'm always going to end up at negative 1, negative 3. And that's kind of the point. You get the same resultant vector no matter what order you use all their vectors in, which makes sense. I mean, you know that intuitively, right? If you give 3 of your friends, like write down 3 sets of directions, like move whatever left and right, move whatever up and down. Give each of those to 3 of your friends. Have your friends decide like a random order in which they're going to give you those directions. Start at the same place, follow one order, see where you go. Go back to the original, have them give you a different order, follow those directions. You'll end up in the same place every time. It doesn't really matter. You get the same resultant. So let's do this on paper, or I mean, I'm doing it on the iPad. But I think like playing around in GeoGebra like that is pretty helpful because you can, if you're wondering what happens, just do it. It doesn't really take that long. So I got a U plus V minus W. So first thing I'm going to do is I'm going to write down that negative W is negative 3, negative 2. All right, here we go. And let's see. I'm going to say that U is going to be this color when I use it. V will be this color when I use it. And then negative W will be this color when I use it. So First up, U takes us from here. Oh, well, it's supposed to be using a marker though. Okay, here we go. Sounds like someone, birds like to fight, it turns out. And I don't think you can hear them, but it's crazy. V, 1, -2. Take me to here. So like outside my window right now, there are some birds just going nuts. This is V. And then -W is 3 to the left and 2 down. 3 to the left and 2 down. Just gonna take me to here. So this is -W. Okay, and then my final vector, which I'm gonna use just black for, I think, here is U plus V minus W. And you could definitely just get it by dealing with the components, right? Just like treat it like matrix addition or subtraction. That'll work out for you like really quickly. Let's try the other one. So it was first we're gonna do V. So V is 1, -2. So that'll take us to here. What's kind of interesting is when you do it this way, sometimes you like need, like the order in which you do it might take you off the grid that you were given, which I always think is kind of interesting because like the resultant vector is going to be the same no matter what, but sometimes you actually don't have enough space to do it the way it was given. -W is 3 to the left, 2 down. So 3 to the left, 2 down is going to take me to here. That like snap to line thing is amazing. Obviously things end up looking a lot better because it will do that for me. And then finally use U, which is 1, 1. Bit of an extreme angle there. That's U. And then our final vector goes from the initial point, which was right here, to the terminal point, which is here. And there. And this is, what is this? This is V minus W plus U. So it doesn't matter what order we do it, we will get the same resultant vector, the resultant vector. So in both cases, this and this give us -1, -3. So we go 1 to the left and 3 down. In both cases, that's what our resultant vector will be. All right, so I'm gonna stop this here. I'll be back in the next video and we will do more stuff with vectors. So I hope you are finding this helpful.